So say you typed in the correct answer, just was a fraction instead of decimal. What percentage of the score would you actually get back? Or is it just question to question basis?
Something like that, I'd probably do like 0.9.
Okay, I'm happy with that.
Yeah. Okay, and then we also have the two quiz 6 and quiz 7 to do with the de Sitter both over quadratic functions. So I know that's a lot of work. Unfortunately, that's just kind of how it goes in the summer.
Woo.
Alright, so let's talk about quadratic functions and let's talk about some of the basic properties. Okay.
Are we going to cover assignment 6 and assignment 7 today?
All of 6 and part of 7, so it's just 7 and 6 and due.
Okay.
So, are those going to be only, exams? 6 and 7?
No, the exam only covers up to last week. That's a good question.
Ooh.
Only up to assignment 5 is on the exam. Okay, so standard form of a quadratic function is y equals ax squared plus bx plus c. Okay, where a, b, and c are just some numbers. Okay, so the x squared is what you're looking for. If you see an x squared, if you took away the x squared, then you would just have a linear function. If you put the x squared in there, it becomes a quadratic. Okay? The other way that they can write this is in what is called vertex form. Vertex form is a times parentheses x minus h squared plus k. Okay, you guys have probably seen the standard form before, but you might not have seen the vertex form.
Heard the word vertex form, but I've not seen the equation.
Yeah, the vertex form, H and K, they use different letters just to say that these are not the same as B and C. So those are not the same letters. A is the same number. So if you have A in one equation, it'll be the same A if you write the equation in this other form.
Okay.
Okay, so that A is the same A. Okay, now what does A tell you? Okay, well first of all, what is the graph of a quadratic function called?
Parabola?
Parabola, yes.
Maybe it'll be
They don't really have slope because it's a curve.
So would H and K be points on, say, a parabola?
H and K actually is the vertex.
Oh, itself.
Yeah, we'll talk about that later though. I know what A tells us.
If it's concave up or concave down.
Concave up or concave down, perfect.
So positive A would result in a concave up, or a bowl shape, and negative would result down? Okay.
Okay, so that number A tells us whether the parabola is concave up or concave down. So when your A is positive, okay, guys remember, this is kind of cheesy, but you can remember positive is happy. So it's like a smiley face. That's concave up. And if A is negative, that's like a frowny face, and sad. That is concave down.
psychology.
Okay, so super easy. All you have to do is look at that number stuck out in front of your equation and see if it is positive or negative.
So a is always the number next to the exponent.
A is the number next to x squared. Okay? A is the number next to x squared. It's not just the first number in your equation. It's the number next to x squared. Sometimes they'll try to trick you by putting stuff out of order, but A is always in front of x squared. Now, if you guys can't remember which way this goes, what is our friend, our best friend? Ashley, what's our best friend?
Rentcalculators.org.
Rentcalculators.org, okay? Guys, if you are drawing a blank on these, all you have to do is graph it. Okay? You can tell a lot from the graph of a quadratic function. You can see a lot of stuff. Okay? So remember, the graphing calculator is your friend. Okay, so we know whether the function is concave up or concave down. Let's talk about points on the graph. Okay, let's just pretend we have a quadratic function that is concave upward for now. Let's draw that concave up. Okay, now there are 4 special points here that we care about. Okay, what are those 2 points called?
The intercepts, yeah.
2 x-intercepts. Okay, and from now on, instead of calling them x-intercepts, we are going to call them zeros. Okay, so they talk about finding zeros. They were talking about x-intercepts, just like we have before. Okay, what else do we see on here?
We have one y-intercept.
1 y-intercept. Okay, and the y-intercept is very easy to find. We'll talk about that in a second.
And then the very bottom part, wouldn't that be a point?
This point?
Yeah.
What is that called?
Well,
That's called a vertex. Who doesn't like to write in green? Sometimes I need to write in green so I need a different color.
How weird.
Okay, and that's green. I don't know. It used to be okay with green. I know it's not. Okay, that is the vertex. Okay? If your function is concave up, the vertex is a minimum point. If your function is concave down, the vertex is a maximum point. So if you're trying to figure out if it's minimum or maximum, just kind of do a little hand signal thing. You know, if you look at a U, the vertex is going to be at the bottom. You make an upside down U, the vertex is going to be at the top. Minimum or a maximum point. And let's talk about how to find the y-intercepts. The y-intercept is so easy.
When you're saying concave up, it's vertex is the minimum point.
That means it's at the bottom of the bowl.
Okay.
So it's the minimum, the lowest point on the graph.
Okay, so the bottom.
The bottom point, yeah. And then the maximum point would be the top point if it was upside down. What's that writing here? Y-intercept. Now, how do we find the y-intercept? Do you guys remember?
Set x0, x to 0.
Plug in. Remember, to find the intercept, you set the opposite variable equal to 0. Okay? So to find the y-intercept, set x equal to 0. Okay? Now if you're trying to find the y-intercept, generally we want to use an equation in standard form.
Well,
Okay.
I get it now.
So what's going to happen here if I set x equal to 0?
Your first two become 0.
My ax squared is going to become 0. My bx is going to become 0. And I'm left with just y equals c. That is always the y-intercept, is that constant term without an x. Okay?
So that's the intercept, C?
That's the y-intercept is c.
And if there isn't one, then it's inherited 0. Or
If there's no constant term, like if c is missing, then the y-intercept would just be 0.
that's what I was thinking.
So you can pick out the y-intercept just by looking at the equation. You can just pick out c, which is the constant term without a variable. That's your y-intercept. Okay, so we can figure out if it's concave up or down. We can find the y-intercept. How do we find the vertex?
Ridiculous.
Now there's two cases for finding the vertex. You need to look at how your equation's written. So if the equation is in vertex form, then you can pick out the vertex from the equation.
So does vertex form the x times, or a times x minus h minus k?
Okay.
Plus k, okay.
Now, you gotta be careful here because h has a minus in front of it that's built into the formula. Okay, so when you pick out that number h, that means you have to change the sign. Okay, so like if you see x minus 2 squared, then your h would just be positive 2 because the minus is part of the formula. Does that make sense?
So you want to think of it as negative h.
Negative h, yeah. The opposite of h is the same as k. Is your vertex.
That looks like a set of coordinates to me.
That's a point.
What does that mean?
It means like if you see
Opposite sign.
if you see like x minus 2 in your formula, then your h would just be 2. So instead of minus 2, you would make it plus 2. Because that minus is part of the formula, it's not part of the number, that's your h. Consider a problem, that'll make more sense. The problems when they start asking about the vertex. Okay. Are you guys okay with graphing these? Graphing calculations? Number 7. Okay, so this says y equals x minus 4 all squared plus 1. This is number 7.
Wouldn't our coordinate be 4, a positive 4 and 1 as our vertex?
Positive 4, positive 1 is your vertex. Exactly. Okay? So the minus 4, the minus is part of the formula, so your h is just positive 4, which is the x coordinate. And your y coordinate is just the number hanging on at the end, which is positive 1.
Okay, now where are you seeing H here?
Now you're gonna use that and like you
You
have
compare
there.
it to that general formula with H and K. H is the number after X, in parentheses, K is the number at the end.
Now because this says negative H, you're gonna think this is 4 and combine the two, so negative 4. Because you're using two negatives. Had that said X plus 4, it would be negative 4, right?
Mm-hmm.
So just think of it when it's two negatives, it makes it positive. When there's a positive and a negative.
But K would stay the same.
K stays the same, H change sign. Change sign.
Okay, so that's supposed to be an H here, and this, where's the K at?
The K is over
X.
here. Plus.
Okay, because this 4 drops over to here. So would this X also be the K in this?
No, you're just
Now how do
this
I
is when you use our H and K.
how do I figure out the graph here?
Go to C. Zoom it out.
Calculator.
Okay.
Graphing calculator.
You can use the graphing calculator. But the trick here is that once you know the vertex, only one of these graphs is going to have the vertex in the right place.
C.
Okay? So I'm looking for X is 4, Y is 1. Okay?
A is
So 4, 1 should be my vertex.
A is 4, 0. B is 4, negative 1.
A is 4, 0. Y is 0. So I'm looking at this vertex. This would be 4, negative 1. That looks like 4, 1 for my vertex. Okay. See how the bottom point of my parabola is that X is 4, Y is 1? That's what I would look for. You're always only going to find one that has the right vertex. Unless they have
So
two.
you don't really need the graphing calculator.
You don't really need the graphing calculator here. You can usually use process of elimination on these. They may have two that have the right vertex, but if two have the right vertex, then one of them will be upside down. So it would be concave down instead of up. So you can always pick out the graph just by.
Say that one again, please.
So always the case with the graphs is that there's only one. Usually there's only one that has the right vertex, and if they did have two that had the right vertex, then one of them would be upside down.
Okay.
So you can eliminate it.
Where inside the vertex format would you be able to determine if it should be positive concave or negative concave?
The number in front of the parentheses tells you the concavity. If there's not a number here, I just assume it's positive 1, which would be positive. So usually if they don't have a number hanging out there, it's just positive 1.
Oh.
Did I catch everything I said there? Am I needing to repeat anything? I know I'm going kind of fast today. We just kind of want to cover.
Yes, you could. That would be great. I'm sorry, my ears totally clogged up today. Just the last part.
About using process of elimination on the graph?
Yeah.
You're looking for the graph that has the right vertex.
Right.
And you also want to make sure that it should be concave up or concave down. So like if you see,
your equation wrong.
like here I know my graph should be concave up. These are all concave up, so I can't eliminate any of them. But sometimes you can eliminate them based on the vertex being wrong or the concavity being wrong. If you can't figure it out, still just use the graphing calculator. It's always an option. Okay, what about this one here? Let's look at what's going on here. First of all, they've got a negative in front of the parentheses.
Parabola upside
See
down.
that negative 1 hanging out in front there? That negative is kind of easy to miss. That means this is going to be concave down.
And we have to distribute the negative, don't we?
Okay, so this is number 8. It says you don't distribute the negative. You cannot distribute inside those parentheses because of the exponent.
Okay.
Outside.
Yeah, because
You only want to think of this as minus negative 3. Okay? So you don't need to actually write that down on your paper, but In order to get this in vertex form, I want to think of this as minus negative 3. And the square should be outside there. That's easy.
Okay, so the reason why you don't distribute is the order of operations exponents are first.
Yeah, that square, the square outside those parentheses would keep me from taking that negative inside. You'd have to square all that out before you could distribute. Which I don't want to do that though. You don't ever want to do that.
Okay, so you're saying that we can think of it this way because then we can compare it to our vertex form.
Yes, I want to think of it this way so I can compare it to my vertex form. So my h would be negative 3, and my k would be negative 1. Okay, so I've got x minus h would be minus negative 3. My k would be negative 1.
Now, will that h flip over to a positive there?
Well, no, I already flipped it. See, I flipped it from plus 3 to minus negative 3. Okay, if it starts out at positive, you flip it to a negative, and then you want to keep the negative.
Interesting. My problem for question 8 was positive.
Mine was too. I had to use hers.
Okay, so I'm looking in my graphs for the vertex in the right place, and also that negative in front is going to make it concave down. So I can just use that process of elimination to pick my graph. Okay. Which one is completely wrong? And if I ever see you guys choose this one on a test, I'm going to be so upset.
B.
D. What is wrong with D?
It is not a function.
It's not even a function. Do not ever choose anything that's sideways like that. That's a throwaway answer. Stop doing this to me. Okay? No sideways parabolas. Okay? Which one else is completely wrong?
B.
B, because I know my graph should be concave down because of the negative in front. Okay? Now, between A and C, I can just look at the one that has the right vertex, negative 3, negative 1.
A.
It's A.
Yeah.
Okay? It looks like C would be positive 3, negative 1. So the vertex form, you don't need to do anything to the equation. Don't try to FOIL it. Don't try to distribute anything. Just look at the equation, compare it to your vertex formula. That's all you have to do.
Does anything change when we have an A value, which is the next question?
No.
Okay, so it's just the same thing we just did last time.
No. All that 2 there tells you is that it should be concave up. Yeah, this is the exact same question. Okay, so what would my vertex be for 9?
5, negative 4.
Yeah.
Positive 5, negative 4.
We're so smart. That makes sense.
Now, what if we have to find the vertex and it's not in vertex form?
Make it vertex
Do
form.
I want to try to put it in vertex form? You can do that, but you don't want to, trust me.
Okay.
Okay?
What's standard form?
Standard form. So we need to know how to find the vertex when our equation is in standard form. This is where you're going to have to do a little bit of work.
Is that problem 10? Yeah.
Okay, so standard form is ax squared plus bx plus c. A is the number in front of x squared, b is the number in front of x. vertex is x equals, anybody know this formula? Negative b over 2a.
Oh.
Negative b over 2a. Have you guys seen that before?
Yes.
Negative b means the opposite sign of b. So if b is positive, you make it negative. If b is negative, you make it positive.
Negative b over top of 2a?
Negative b over 2a.
So this is the vertex coordinate, right?
This is the vertex. This is the vertex when it's in standard form.
Okay.
That's the x coordinate of the vertex. Now once you get your x coordinate, what do you do to find the y coordinate?
You fill it in.